my name's Stacy Hubbard. I teach 7th grade science at Westport Middle School, and today I'm going to talk about engagement in my science classroom, and hopefully you'll pick up a few things that I do and maybe be able to incorporate in your classroom. So today what I'm going to do on the focus of this session is I'm going to show examples from my classroom for the following: rich tasks, collaboration, discourse, and some of those ideas are going to overlap. I might be saying I'm talking about collaboration, but it might be also referring to rich task. A lot of these things just kind of intertwine. And then while you might not teach some of the grade levels I do, hopefully you'll be inspired to incorporate some of these ideas I present here and adjust them for your grade level. So the first thing I'm going to talk about is rich tasks. So those are those tasks that are grounded in students constructing knowledge and making meaning through these important activities. Before I show you anything, I really want to give credit to my PLC. We meet like 4 days a week during NTI, and I work with my PLC to create many of these really rich activities that we use daily. So I owe so much to them for working with me to create this engaging work. So I just wanted to say thank you to Darius Romlo, Angela Daddario, and Ashley Green for putting up with me daily. So some of our planning strategy when we're trying to look through a unit and what we need to get done is we try to look at our district's core curriculum because it's designed to meet our NGSS standards. So we look there first. So then we'll ask our question: what is included in our curriculum that can be modified for online learning? So hopefully we can modify some of that stuff. And then if we can't, are there other activities or resources that will help maybe build some of those bridges, some of those gaps to help them meet the standards that maybe we cannot carry over from our core curriculum? And then we also ask her some questions like, are these activities equitable? Because obviously we can't assume that students have certain resources at their house. What can we do to make sure that certain things are equitable? And then we try to limit the number of technology tools that we use so students will feel comfortable using core tools and not feel like they're constantly having to learn some kind of new tool. And then they're working on learning a new tool versus really kind of learning what they need to learn. So the first thing that you probably is wondering is good ways to replace hands-on labs, because that's the toughest part. So students don't have the materials to do these hands-on labs. So what resources can we use to help them get this experience? You can do simulations, and some things that you don't even think you can do simulations on, you can find outside of FOSS. Some things are inside of FOSS. Like for example, we had to do a microscope, and they can't get their hands on a microscope right now, but it's important for them to understand what a microscope does for what we're doing, because we're actually looking at cells. So what we did is we found this virtual microscope, and not that they had to memorize everything, but just we let them play around with it so they could kind of get familiar, and then they could even do some of the activities that we did in class. Like this one, this part of the simulation was they got to look at a letter E, which is what we do in class. And so they got to adjust it and whatnot, and they could change their magnification. And so we got to actually have a lot of the conversation that we normally have in class. So simulations can be very useful. It's just, another way to get them to use that. There's another simulation we used, and this one was in FOSS. This was in our curriculum. We just kind of use this since it was already there, and they can talk about the human cardiovascular system when we were talking about body systems and getting ready to talk about ACR. And the kids could kind of play around with this. You could give them questions on if you wanted to guide them a little bit more. But I think simulations are a great way, especially when you get into physics, to help kids understand some of these concepts. You could also do videos. We normally would have the kids look under the microscope at Elodia and paramecium, for example. And so we used Nearpod here, and you're going to hear me talk about Nearpod a lot because we used a lot. I know some people use Pear Deck, similar. You could probably do the same thing in Pear Deck. I'm just not as familiar with it. But instead of having the microscope, we would have a video blown up at the same magnification. And those questions that would be on our worksheets, normally in our notebook, we just kind of had throughout the video. And since it was Nearpod, we could then have a conversation about it. Like, what do you see? What's going on? What do you think's going on here? And we did that for anything we needed to look under the microscope. So we did it for the Elodia. We did it for the paramecium. We even did some questions where we ask them things that to extend their thinking. Well, do you think, we were looking at a plant cell. Do you think, or we're looking at a leaf cell. Do you think a root cell or a stem cell would look similar? And kids would have that conversation. And as we moved along, so we were still having that conversation and having that rich discourse. And I could see their answers as they were typing them in, and they would share them with me as well. And I can share them so anonymously if I want it, and so that the other kids don't have to know who's saying what. But it was really nice because you could see, like, again, these videos, and they were at the right magnification. And it was, I think the kids started to get at least that idea. You could also use pictures, especially if you're getting into modeling. I think pictures can help a lot. Having kids draw on them. I'm going to talk about Jamboard. You can do drawing in Jamboard on pictures, or you can use Nearpod and you can draw on these pictures, and kids can kind of manipulate those models. So you'll see, like I said, Jamboard and Nearpod are those good resources to guide them experiences and actually help you with questioning, and so to see what kids are understanding. You can also allow them to do things using their own household items. Some things I just made optional, like, hey, if you've got this, you can try this. Like if you want to grow your own plant, you want to try hydroponics, you could do something simple as make your own ecosystem, or you can make a water drop microscope. So I gave them like directions if they wanted to try that. So those are more hands-on type things that they could try if they had some of that stuff at home. Some of that stuff was not mandatory though, because I didn't feel like it was equitable. They may not have those resources. Some things we could do, like, take a picture of, a plant outside your house or something like that. But some things it's just hard to make sure that every kid had it. So another thing I think is important when you're talking about rich task is providing choice. So we did a lot of create your own organism. Since we were talking about unicellular, multicellular organisms, we use Nearpod for that. You really didn't have to. You could, but we had them say, think about if your organisms could be unicellular, multicellular. How does it do those 8 characteristics of life? What features do you want it to have? And they were supposed to draw and label it, or they could make it 3D and they could insert a picture here of what theirs is, and then they would just describe it as part of their project of, like, how does it carry out the functions of life? What are its features that help them do that? So it was them creating their own understanding and being able to communicate in a different way rather than just pencil and paper tests. We did also create your own cell analogy, because the kids did do some tasks where, we need to understand that a cell is a system. That's one of our cross-cutting concepts. And we used a model of analogies because that helped them understand it. So we did some together, but then on their own, they could create their own. So they could pick anything they wanted. I gave them some examples they could pick, or they could pick anything they wanted, and they just had to tell me the connections. And we just used Google Docs for this. I did have them draw a picture at the bottom, or they could make a 3D model and insert a picture. Just showing me something of that. So again, just kind of this 3D modeling experience and how these parts work together to make a cell living. And then the last thing I was going to show you with choice was the cell menu projects. Was another way to give them some choice, so that we could just make sure they're understanding that how a cell works. So we would give them different options, and then to make it equitable, we would give them templates for the options. So if it was a brochure and they wanted to pick the brochure, they could make their own brochure by hand and give us a picture, or they could use the template that we had here, which was a Google Draw template. Because I know some kids would have materials at home that they'd be able to draw and make things and maybe do some of the 3D things that other kids maybe wouldn't necessarily have at home. So we gave them templates to at least get them A, started, and B, a place to go if they didn't feel like they had other things they could do. But they had options. They didn't have to use the templates, but the templates were there. They just had to make copies of them. So that was kind of the way that to give them that choice really helped give rich tasks and get some of that buy-in that, okay, I understand this connects to me. This is my real world phenomenon connections. So next I'm going to talk about collaboration. So for collaboration, obviously, you've got these rich tasks, but in a lot of those rich tasks, you're going to be collaborating. Like so I thought I'd pull out some other assignments I thought had a lot of collaboration in it. because we want to get that sense making, kids working together. So for synchronous learning, I usually use breakout rooms like a lot. So here's some strategies if you haven't used them or if you've used them and you haven't been successful. They do have their advantages. You can easily make groups as big or as small as you need. I tend to make them pretty small, like 2 to 4 people. At the beginning, I was making them kind of big, and you could tell people were getting lost in them. They were just sitting back and not really participating. You'd have one person or 2 people kind of really driving it, and the rest weren't doing much. So one thing that's nice is you can really make them small quickly. I encourage my students to screen share. And so one way to do that is you can assign roles. So if you have 4 people in a group, you could have one person be the scribe. So maybe they're the person that shares their screen for the group, and they're the ones kind of going over and like typing what the group is saying. You have a facilitator that, again, can help kind of with that time management piece, and if there's any disagreements, kind of being like, okay, helping the group work through that. The reporter would be the person who shares out the information when we go back to main group. Now the other group members are supposed to be able to respond to questions too, but they would be the one that brings out the original information. And then the director might be the ones that reads the directions to the group and maybe goes and asks questions to the teacher so that the group understands what they're supposed to do. So those are similar roles that we do in class. You just don't really have like those material managers type thing and the cleanup and things like that. So what I do to kind of make sure they are doing those roles and staying on task is I just kind of do constant check-ins with probing questions. And then I'm asking each person in the group what their response is so I know that they are participating. So here are some examples that I'm going to show you of ways that I kind of got kids to collaborate. Again, I don't use a lot of different tools. I mostly use those breakout rooms. So this one was, we had been doing some work on body systems and how they interact. And we had a mystery patient that was our phenomenon from the start. And so along the way, they've been learning about different symptoms the person had. And now we're getting to the point where, okay, we've learned about all our different systems and how they interact and what they're made of. And now we need to diagnose our patient. So this is kind of coming at the end of the phenomenon. And so this slide here, the group just kind of worked together. So they're split into groups and they work together to determine like where each symptom, what system might be impacted. So that was just kind of a review of the systems based on her symptoms and other information. But what was cool is I made different breakout rooms. So you had groups that were hantavirus pulmonary syndrome. You would have a group that was lupus and a group that was Lyme. And I would name their breakout rooms these groups. Okay. And what I did is because I didn't want these groups to be real big, I had like 2 HPS rooms. I had about 6 rooms total because I would have 2 lupus rooms, 2 Lyme rooms. And then what they would do is they would only research their one disease. And so they had a reading that, this is all, again, coming from our FOSS curriculum. They had a reading that they had to go through. And then as a group, they just had to fill in this slide. What were some important facts about the disease? Tell us some things about those symptoms, that they would have if they had Lyme, and then your conclusion. Do you think this person has the disease and why? And so the Lyme groups kind of got together and shared their notes to see if they were kind of had something similar. And the lupus and the HPS got together, and then they all got together. And it was really neat to see, because normally when I was in class, I would have you would partner up and you'd work together and you would look at all 3 diseases. But I really didn't actually have a lot of time to do this. So I decided to try to make this a little shorter, and it was really kind of cool because it was funny. Some classes, everybody thought theirs was right, that their patient had their disease. I think they just wanted them to have their disease. But once they got into the big group and they heard what the other students' disease that they had that they researched, they kind of started changing their mind. And you could hear a lot of discourse on, no, my group thinks it's HPS because she has this, yours doesn't have that. And so there was a lot of discussion in the end, and you could see a lot of people coming around to what the actual diagnosis was and kind of changing their mind. So there's a lot of discourse on that, but a lot of collaboration too. So we're going to talk about discourse in a minute, but this was a huge collaboration effort. Another thing that you can actually, I thought I'd bring this up, that you can collaborate on is readings. So what I had kids do, because I just Sometimes, you can annotate a reading, you can do whatever, but I kind of wanted to change it up. And the idea here is they had to try to summarize a section of a reading in a sentence. And so what I did is I had them go into breakout rooms, small breakout rooms, like 2 or 3 kids, and they would take turns. They would read, and then they would each kind of on their own write a sentence, and then they would take turns being the first person to share out. And then they would work on, okay, let's make our sentences better. And so it was really neat because they had to take turns each time. It couldn't always be the same person sharing out their sentence. And then they would work through it. And then sometimes once they got later on, they could work on putting that one sentence together instead of individually coming up with it. So it was a big collaboration effort to work through that reading. But it was really neat because after this, we actually had some discourse too. And people kind of changed their mind on what they thought was important things. And I said, well, wait a minute. It doesn't mean you're wrong. This person just picked out something different than you. So it was also not only collaboration, but really cool discourse. The other thing I was going to show in collaboration is a way to use Jamboards. Is again, I used a lot of stuff from FOSS, and so I just kind of manipulate it. And this is a lab on Mono Lake. They would have already done all this research on Mono Lake as they would have done in this reading that you saw, and they would have watched the video and all that stuff. So they would already had a really good understanding of Mono Lake. And I just kind of extending it to food webs and reviewing food webs from what they had learned previously. And so what's nice about a Jamboard is you can draw on it. So I basically just added things that this would have been there in their notebook pages. I just put it in a Jamboard and they could just kind of draw on it, like find me a food chain in here, find this food chain, and they could highlight it, things like that. And then we went into Mono Lake because they had learned Mono Lake, and that was actually my warm-up. Like, what are the organisms in Mono Lake? What do they eat? That kind of stuff. So they have a separate slideshow that tells them what eats what. It's actually all the different cards with what eats what. And I just took these cards. These are in FOSS-Web, and I just cut them and pasted them into this Jamboard. And I did the same thing with the slides that has what eats what. I just copied and pasted what eats what into slides so they could refer to that and then make their food web. And then as a group, when they were collaborating, they could just move these cards around. Again, the person who's a scribe is the one bringing this up, and they could all talk about, okay, what are we going to put first? Where are we going to put our arrows, and how do we make our food web? And I didn't give them any instruction. This is just them exploring and collaborating together. And then first they would have to make a food chain. So they had to make a food chain, and then I would check them. I'd come around and check their groups, and then they would actually have to make the whole food web. So it was just like what I would have done in class. I would have done the same thing. I would have come around to their groups. I would have said, do you have a food chain? I would have said, asked them questions, if they had their arrows correctly, did they have the right organisms? And then once they had that, I'd say, okay, now go make your food web. Go look at those cards and look at what eats what. And then so they could collaborate. And then they just kind of did it again. I gave them more information, and they would collaborate again. And like, okay, how can we fix our food web? And then in the end, they were able to, once they did all that collaboration, they were able to analyze that food web. So it was a pretty rich experience that we already had. And in our curriculum, it was just modified. So the last thing I want to talk to you about is discourse, which I've kind of mentioned already, because like I said, a lot of these things overlap. Okay, so for discourse, like I said, I've mentioned this. You're going to connect your thinking with your peers, or they're going to connect their thinking with their peers. So here's some opportunities that I think you can do. So you want to reach those reluctant students. I know that's really tough. So use questions or share opportunities that are kind of low risk. And what I mean by that is I kind of use at the beginning of my class like a riddle or joke with my content question. So you're going to see an example below here where the first question is where they have to identify an example of Mono Lake. Okay, that's their content question. But then the second part is a riddle of the day, and sometimes it's a joke, it's a riddle, whatever, but it's just something simple. And what begins with T, finishes with T, and has T in it. I think the answer was like teapot for this or something. And it's really neat because some kids it just really gets them laughing and joking, and it's funny to see what some of their answers are, and some of them are creative, and some of them are like, that could be an answer. So it's just kind of low risk. And so when I put them into small groups or their breakout rooms, sometimes I'll do the same thing. I'll do like a this or that. So I tell them, like, when you get in your breakout room, before you start your assignment, I want you to choose Coke or Pepsi. And so they have to talk about whether they like Coke or Pepsi and why. And then they start working on their assignment. So it's just kind of like a little icebreaker. I encourage chat and or verbal interactions. I know some kids just do not want to get off either the microphone doesn't work, or they just do not like to hear their voice. So I always say, like, you can unmute or you can type in the chat. I always give them multiple ways of interacting with me. I use Google Meet or Google Classroom polls. I usually use Google Classroom questions like the one down here, because I like to see who's answering, whereas in Google Meet, it's kind of hard to tell that. But you can use those just to kind of get kids interacting some more. It's kind of low risk again. And then sometimes I kind of will look at a student's work and then ask them if I can share it for them. And then sometimes what I'll find is when I do that, the kid will kind of chime in and say, well, what I meant here. And it kind of gets those kind of people who are reluctant, who know their work is good, but just kind of, I'm a little reluctant, but you can share it for me. That's another way to actually get that out there and get them kind of going. So I talked about using Google Classroom questions. And so I like to ask those questions, and each student will answer it. And then I allow students to see and respond to each other's answers. So that's another way to get discourse going. And this is a good way to get that asynchronous discourse going. And those that don't like to talk in class, they usually don't mind typing in answers. So again, this could be synchronous or asynchronous. So I just kind of put here a picture of when you go to assignments in Google Classroom and you hit create, you would just hit that question. And then, I don't know if you can see it right here. Whoops. But if you look down here, if you click, students can reply to each other, then that allows them to talk back and forth, and you'll get some really good discourse that way. Some kids who don't like to talk in class will start kind of communicating in that method. You can also allow them to edit if you want. Sometimes I'll do that with warm-ups, like we'll have our discussion, and then I'll see a bunch of kids in there trying to change their answer, which is totally fine because I just want them to change what they already did. Another thing you can do is page Keeley probes. We've done these in class, but I've found them very valuable in NTI. They really help me find those misconceptions quickly. I have them complete it prior to the lessons that I'm going to teach, just kind of like a pre-assessment. And if possible, if it's something that's like an argumentation, I'll have them vote in a poll in Google Meet or Google Classroom to see where people lie, so I can kind of tell who's got what misconceptions. And then after the lesson, we'll do it again and kind of see if we, have different answers this time. Just note her probes focus on DCIs. They're not so much on using SCPs and CCCs. That's what you'll have to incorporate into your daily learning. But if you're trying to see if they still have some misconceptions, the probes are, I think, awesome. So I wanted to show you one. This is kind of a picture of her book. If you search anywhere on Amazon, you can get those. But here's one that I do. It's called Food for Corn. And what they did is they had farmers. We were getting ready to talk about photosynthesis. You had farmers talking about food their corn needed to grow. And the students at the beginning would just say, who do you agree with and why? And then after we did a bunch of lessons on photosynthesis, then they came back, reread this, and did the same thing again. Now, who do you agree with and why? And they kind of tell me more about who they agreed with. So the discourse was really cool on this. Normally, when we're in a room, I have the kids stand around under signs with whoever they agree with. I had them do the voting, and then that was kind of low risk because I didn't really know. I didn't want to point out who voted for who. It was just, okay, let's talk about it. But it was really neat to see. We could kind of narrow it down once we had our discussions. We narrow it down to about 3 farmers because most kids get the kind of common understanding of photosynthesis, but they miss the main point here. So we narrow it down, we'll have like a conversation, and then you'll get people who are diehard, like picking one that's close but not exactly right, and you have people just going back and forth. So we have some really good discourse there. And this is really usually one of my main things. They just love to argue about who they agree with and why. Another one, so that's your food for corn. And then, like I said, Jamboard and Nearpod are my go-tos. One way to use Jamboard is maybe put your focus questions on different slides for your unit. And then as you get to them, you can have kids add Post-its of what they've learned to help them understand that focus question. And then at the end of the unit, you've got this huge review board basically for the students and things that you all have tracked. So that's pretty cool. I was going to show you though that we did a See, Think, Wonder way of Nearpod that is a good way to get people talking. So what it was is you had frames. We did this at the beginning of the year, but we've done it several times. but this was a picture of a scientist in the field, and they were just trying to say, looking at the picture of scientists, what do you see, what's happening, and what makes you wonder. And so they would just put this is like a collaboration board and Nearpod, where they would just kind of post what they see, think, wonder, and it was neat to hear the discourse of different things that people saw on the pictures, what they wondered, and the questions they had were pretty cool. So we had some pretty neat discourse around that. And this was where we were just trying to get them to see that scientists don't have to be in a lab. They can be out in the field. They can be anyone, just trying to get them to see themselves in science world. But you could do this with, like we did this with an ecosystem, like a picture of an ecosystem. What do you see? What do you think? What do you wonder? So those get some really good discourse going. And we use Nearpod for a lot of that. You could use, again, but you could use Jamboard too. Another one we did is, this is another Nearpod, and this is getting them to use their own ideas and kind of connecting it in Nearpod. But this is when we were coming up with definitions. Instead of doing like a normal Frayer model, we just kind of said, okay, here's a collaboration board. I want you to put a post that says, recreate your own definition of what non-living means. Use one post and use it in a sentence. And then so that's where the discourse kind of came in, was they could heart each other's posts that they agree with, and they could respond with their posts saying, well, I agree with this, or what do you think about this? And we had a really good discussion, because a lot of people's definitions had things about being dead as non-living. So we had to have that discussion, and kids caught it and kind of called each other out on that. So that was kind of helpful. And then the last thing I was going to show is living versus non-living card sort. One thing that I really did, and this is again this one is something that was in FOSS, and we normally would have cards, and we have kids sort and living into non-living. And I just found the electronic file in FOSS, and I just copied those and made those all pictures and put them in here. And then I put them in breakout rooms, and this was pretty small. I think they were only groups of, again, like 2 or 3. And they would just kind of have discussions of, after we knew those definitions, what's living and what's non-living. And they had some really good conversations about it. And then when we came back to the whole class, we kind of had a discussion. Where do you put this and why? So card sorts are a really good way of having some really good conversations in distance learning. You could have it in class, but you can also have it in distance learning. So that's all I have for today. I hope that this gave you some ideas of some things I do. I know, again, it was pretty specific to what I do, but maybe you can use that as a springboard to help you have ideas of things you could do in your classroom to help engage your students.